cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
Yes. That's so cool.
It's okay. It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
Yes. It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Here we go. We're live. We're live. Live. Hello, everyone. Hello. Welcome to a especially exciting Friday live stream. Hopefully, everyone is getting to the weekend. I am here today with our esteemed Charly. Charly, our tech lead for Postgres. How you doing this week?
Hey man, I'm doing great. Thanks. Yeah.
So Charly's going to be joining me every 2 weeks. Okay, so we're actually going to be going live every 2 weeks with a specific Postgres topic. We've actually got 20 weeks mapped out. So 20 weeks of Postgres awesomeness, and we're going to be building upon all of the Postgres stuff that we've been doing in previous streams. So if you follow along, you come along for the journey. You're going to find some really interesting things. There's going to be lots of different topics. We hope that you will swing by every other Friday at 2 p.m. Eastern. And we're going to also be doing this with MySQL starting April 1st with Marcos Alba, who's going to be joining us to go through the exact same things, but for MySQL. So if you are interested in one or the other. So every week there will be something streaming from Percona, and we'll be able to cover whatever interesting topics of the week come up. And you'll be able to end the week on a good note with me, Charly, or Marcos. So that should be exciting, right? I'm excited. I'm personally excited. What about you, Charly?
Yeah, no, that's totally, that looks really, really awesome. And the good thing is, even though we have sort of an agenda, right? So this isn't an open talk, right? So we can talk about what the audience, what the people there, they want to discuss. Like, for example, we are being asked if we're going to talk about PostGIS, right? Well, maybe not today because we haven't prepared, but like those are things that we're really interested to hear from what they want to discuss. Right?
Absolutely, yeah. And so we want to make this open for folks. And right now, we generally get more people who watch after the stream than we do during, but that's okay. So if you do have questions after the stream, you can ping us offline. You can drop me a line. You can see my socials listed on the screen. Actually, I'm going to add yours, Charly, in future streams, because since you're going to be here for 20 weeks,
yeah,
we should list where people can reach you as well.
Definitely. I'm kind of unsocial on this perspective.
You're unsocial?
But yeah, no, I do have. I have the Twitter and Facebook things, but like I really don't use them often. I need to learn, like I'm an old person. I'm an older guy. So usually
No, I'm older than you. So you can't claim to be the old man on this stream. That is
well,
not
it's
allowed.
Perspective. It's a perspective, right? So there are aged people and there are old people, right?
Oh, I'm aged? Is that what you're saying? That I'm an aged?
Oh, I didn't say I didn't mean to say that, but like I'd rather be aged than old, I think it's like just like whiskey or wine. You're not old, you are aged, so you get better and better and better, right?
Dig yourself deeper, Charly. Just dig yourself deeper.
Looks like I'm feeling myself in a hook,
Yeah.
The more they struggle, the more hook they get. So I think I'm going to stop here.
Yeah, that's probably a good thing, right? So to slow down a little bit on that. But we are not here just to talk about the weekend and talk about Charly telling me that I'm old. We are here to talk about tuning your Postgres instances and figuring out what sort of configuration variables you should change based on what sort of workload is running. And I think that is an exciting topic that many people have questions on. And we're hoping that you out there in userland are watching, and you are eager to see how to do some tuning. So go ahead, Charly.
Yep. Yeah, definitely. Let's start here, right? Shall we?
Look at that. He just jumped right into it. So I was going to say this. So we have 3 workloads today that we're going to look at. So Charly created a system that has a decidedly Charly-esque workload, which means that it's a box that's falling over. and gonna fall over dead because it's old and decrepit, and aged, as Charlie says.
That's a bad thing.
And I've got two separate workloads that I'm going to throw at Charlie as well.
Yeah. All right. So, yeah, before I go with your workload that I have no idea, haven't seen, that's a good thing. So, because, well, it's usually how we do at Percona, right? So we have customers, they have a problem in their workload, open a ticket, and then sometimes we need just to jump in to help them without no background. So that's your workload. Well, my workload, even though I have some background here, I'm doing not much on my workload. The only thing I'm doing here is a load test. I'm using pgbench. Really, really, really simple stuff. I'm going to show you the command in the fill. But there's nothing special here. So as we can see from this result, I'm getting around 1,800, sometimes 2,000 transactions per second, right? So nothing impressive. And the customer, the user wants to know why our database is behaving so slowly. This is not a super hardware, I should say, but if we take a look, let's take a look on the specs of my hardware here. We have 8 CPUs, we have 32 gigabytes RAM memory, and we have 512 gigabytes disk. So it's a decent box, let's say, that could do a lot better than 1,500 transactions per second, right? So, and then my customer is asking why it's so slow, it's behaving so slow. So we need to go here and start investigating what problems we might have. So we have many, many different approaches. The one that we're going to use here is not the only one that we can use. And sometimes you can also find a different approach that works better for you. So this is fine, right? But one thing that we need to keep in mind is whatever approach we use, we need to be methodic, right? We need to use a method and go through that method. So, and this is what we're trying to go here. So then when I do start to investigate, usually there are 3 things, sometimes 4, that I go first. So first things, it's CPU usage. So I usually take a look on my CPU, on the CPU to see how it's being used. Well, the CPU is under 75% utilization here. There are some extra information, I'm not going through it now, but like just CPU wise, not that bad. It says 75% utilization here, right? So if I go for my disk utilization, well, let's see memory because we're right here. So memory is not bad. So we hear used memory, like really used memory is like just this small portion in yellow here. We still have a lot of free memory that we can use. If we take a look on the swap, we almost didn't use any swap. We see some swap activity here and there, which is usually not good. We don't want to see those activities, but like, it doesn't seem to be the problem, especially because, well, the server is behaving badly for a long time. It's not only those period of times here. I/O, well, it's not that bad. It's getting some I/O, but it's a database, right? It should read and write, so it's writing like reading more than writing on my database here. So, and the disk load here, it's we have some late load here, but like the write load, it shouldn't be that bad. So, what would you say, Matt, from what we see here? What do you have a hint for what is the problem? Where we should go just for those basic information here?
Well,
what
so
would
you're
you
not
say?
using a lot of memory. You're probably have things that are, yeah. And you were seeing some disk I/O there.
Yeah, we do have some disk IOC here.
So we're probably looking at some of the memory settings, and so that's where, you're probably don't have enough being put into memory, reading too much from disk.
Okay, so if we go for memory settings on Postgres, we're talking about which do you have on top of your mind which configuration we go for memory setting? If you don't have, it's fine. Like even I sometimes don't have.
Yeah, like you're talking like shared buffers. You're talking a couple others.
Okay. Yeah, let's take a look on the shared buffers.
By the way,
so I just
the only
changed
one
it.
who asks me questions and tries to quiz me during live streams, just so everyone's aware. like everyone else is just like, let me show you what to do, and I'm off, like getting people on and answering questions behind the scenes, and then Charly starts throwing me like questions, and I'm like, what? I need to pay attention.
Yeah, please. We need to keep it interactive. Otherwise people going to sleep out there. We don't want people sleeping, right? So at least someone should be under pressure. This is how we.
So okay. So now I'm going to go invite other people so they can be under pressure, not me.
Well, you are free to ask for help. Why not? Right?
So who wants to come help me out, live stream wise, while I'm here trying to do this? But anyways, go on, Charly. Let's continue on.
You said shared buffers, right? So let's take a look on the shared buffers. We have here 8 gigabytes for shared buffer, which is not bad, right? Like recommendations for Postgres is not used too much. I have 32 gigabytes of RAM for the OS. So if we have 8 gigabytes shared buffers, let's say the OS uses 2 gigabytes. So we are left with 15, 14 gigabytes for the kernel cache, right? The OS cache that's supposedly to help us with I/O, right?
Yep.
So I would say this value is not bad. Like for this box should be fine. What else could you take a look? Well, if you want to look at anything here, so I just changed it from one dashboard. This dashboard is of the OS perspective, and this is the Postgres dashboard. Right? So just to make sure we're on the same page. So this is the Postgres dashboard. Okay.
So one of the other things is you've got a lot of connections, right? So each of the connections is going to consume quite a bit of memory.
Okay. Yeah, that's a good point. We got a lot of connections. We didn't take a look of how many connections you have, right? So, and yeah, as you mentioned here, we are over, I would say, 500 connections. Right? That's quite a lot for this box.
That is.
Right. So, and it may say something. So we already identified one problem. We have too many connections for this box, right?
Absolutely. So there should be some connection pooling or something there to limit those.
Indeed. And we're going to try with the connection pooling later. Before we do any change, we're going to just switch from direct connections to the connection pool to see if we get any improvement, right? Just like without changing any configuration, I'm just going to stop my load and point to a connection pool, because I have here a connection, I have a PG bouncer there, like just minimize the configuration, listening on the port 6532. So we're going to jump and see if it changes anything. But before we do that, let's keep the investigation. Okay, yeah, we do have too many connections for this instance. We have like over 500 connections here. And if we take a look here on the activity itself, it doesn't look to have too many things doing, because something is really putting my server on its knees, right? And let's go back to the OS.
Yeah,
please.
It looks like you're doing quite a bit of checkpointing as well. So I'm cheating and looking at graphs in the background. You've got some pretty big spikes that are happening on a regular basis. Look at that big checkpoint stats, but
it does.
Yeah,
it does. And from time to time, also we just flush a lot of buffers, like it's expected because of checkpoints, right? So you can ask whatever information for us to take a look here. It's fine. we are investigating, right? So, and sometimes I myself just miss one point or another. So other couple of eyes, they definitely can help. Okay, we have two things, too many connections, and we have a lot of checkpoints. Checkpoints are bad. Well, they're not bad per se, but like when they're too often, they're bad because they bring problem with IOs, right?
Mm-hmm. Yeah,
and
yep.
Okay, one thing that I want to show you here, remember that I said there are some hidden information on the CPU dashboard, CPU graph here, is, see this red stuff?
Yeah, IO weight.
The huge red one? Yeah, this is the IO weight. And this is pretty bad. So what is the IO weight thing on this graph? What is it is telling me here? Can you explain to us in one short sentence?
That's basically you are waiting for IO to complete before you can use the CPU.
That's perfect. So the IO weight is the
way which you said that almost was like it wasn't perfect, but you couldn't think of a good way to tell me it wasn't. And then you were kind of disappointed that I actually got it right. I'm pretty sure that Charlie was trying to, thought like, I'll throw him the
I know you knew about IO.
Yeah.
I wouldn't have asked you, Matt, if I didn't have confidence on you.
Okay.
And that's why I'm asking, because I do have confidence. And that's the thing. So the CPU is wasting a lot of time waiting for IO. CPU is that's the main reason why our CPU is underutilization here, I would say. If we take a look, this green stuff here is the time that the user space, Postgres, let's put it this way, is using CPU. So it's almost nothing, right? Even the kernel, the system time here is doing almost nothing. So, and this huge amount of disk not utilization, but waiting time is killing our server, right? This is the major problem that we have here. We have a huge IO bound system in this case.
Yes.
Right? And this is killing our database performance. Well, we need to find a way to deal with those things. There are parameters on Postgres that can help us, and also there are actions that we can do from the kernel, the OS perspective. Well, at some point, we cannot scale, and we need to either split the load between two different servers or get better hardware for disk. We might get to that point, but we don't know yet. So for what the only thing that we know at this moment is that we are putting too much pressure on our IO subsystem, right? Okay, before we change anything, remember that I told you I would change to use, just show you, this is the command I'm using here, right? I'm gonna change just the port here, instead use the connection directly to the database. I'm gonna use PG Bouncer. So my PG Bouncer has the configuration to only send a max of 100 connections to the database.
So you've already set up PG Bouncer. It's there.
Yeah, I already have one. Yeah, it's there. So I can show you like in a field. And well, if we take a look, looks like we got some improvement. Doesn't seem to be, well, it depends. It's
more
significant.
Consistent. It's more consistent.
Yeah, it is. It is. Exactly. So,
but you could see that in PMM with the different graphs, right?
Mm-hmm. Okay, it's updating here. But even then, we still are putting a lot of pressure, right? We still see here, like from OS perspective. Let's take a look on the connection. So the connection should drop. Yeah, it dropped here. See, this is when we stopped the load. And here is when we got the load back with PG Bouncer. So we have less than half of the numbers of connection, right? So the max number of connections. Sometimes we're going to have more here because the connection dies and it stays open for some period of time, waiting for the kernel to release them. So that's expected to see more than the max number of connections we put here. So that's fine.
And point that, you know, when you start to look, like, for instance, even like your tuple activity there, you could see a pretty significant increase already. It does. Because you're not fighting for resources, right?
That's true. So that's true. And that's a really good point. So even though we still have some limitations here, right? We still have the physical limitation, but now we don't have so many.
He was going to say so many connections, but it looks like we have a internet hiccup. So I will just continue on for him for a second. Hopefully it is not me. So while we try to get Charly back here, basically what we're seeing is the number of connections we're competing.
It's a connection pooler.
Oh, okay, you're back. You disappeared for a second, and now you're back.
Oh, sorry. Yeah,
Oh, and now he's frozen again. Oh, the negatives of having an internet on a Friday afternoon, right? Of trying to do the live stream, but no. So it is interesting because the architecture for connections and threads within Postgres, there is a lot of connection and potential overhead, but tools like PG Bouncer, PG Pool are absolutely required to get the optimal performance out of a lot of these. So we are seeing what's going on. Oh, and look, and Charly is back. Hello, Charly. Welcome back to the live stream here.
I just got a glitch on my connection here.
Oh no,
sorry for that.
I was just saying a little bit about the, how Postgres's threading model and the connections make it so if you do have a lot of users who are going to be accessing things concurrently, there is an important to have either connection pooling or something out there to help manage those. Now, David Gonzalez asked, is there a recommended sizing relation between the maximum numbers of sessions in PG Bouncer pool versus the CPUs in the database node?
The max number of connections we have two different things of max number of connections on PG Bouncer. We have the max number of connections from the front end, that is the connection that PG Bouncer receives from the Postgres clients, and we have the max number of connections that PG Bouncer opens on the database. Which one is he referring to?
Not 100% sure, because the question is what the question is, right? So I think it's just, when you're talking about setting PG Bouncer, is there some magic formula for saying if you've got 8 CPUs, you shouldn't have more than 80 connections set up in the connection in PG Bouncer, or something like that? Is there like some formula that we should be using?
The thing is, PG Bouncer is single-threaded. It uses a synchronous IO to balance. So what it does is, when it receives a connection, it puts in the pool and then waits for the kernel to notify when something is back. Just like normal synchronous IO, we have like epool or IOU ring on Linux, right? So it only has one thread. So it doesn't matter if you have 100 CPUs on your PG Bouncer. If you just install your PG Bouncer and use as it is, it only uses one CPU because it's single-threaded. There are some tweaks we can do to make PG Bouncer to use multiple CPUs, but those are some tricks we need to do. By default, like my PG Bouncer here, I didn't do anything, it's just using one. So, but because it does use a synchronous IO, it can handle really thousands of connections. So because it doesn't get busy all the time with the processing from the IO.
But from the pool perspective, is it something that you want to say, like you've limited here to 200, I think, connections. Is there a limit to the number of connections you should allow to Postgres based on the size of the box?
It is. So I did limit here to 200 because my intention was to show the difference of what we get if we have like just around half of the number of connections from the resource perspective. Ideally, we should not have more than usually like 6 threads per CPU concurrently. Right. So in my case here, I would say ideally I would put 64 max connections as I have 8 CPU cores. So I put a lot of pressures here because they're going to have around 8 process per core. So in average, but it's fine. So we wouldn't have too many context switching, and so it's fine. But when we are moving for a number that's too higher than that value on the Postgres per side, so we can the box starts struggling with resources.
Okay, fair enough. We got a comment from Augustine who said our mics were a little hot or cold depending on which of us was talking. Hopefully that clears it up a little bit. I made some adjustments if the sound went a little wonky. Oh, and Augustine says much better for both of us.
Cool.
So that is good. So I'm glad someone out there is watching and letting us know. Because, if we're going to do this every week, we want to save these settings so we don't have to go through that. But okay, so Charly, where we were was we were looking at the connections. We dropped the connections. We saw that. We were getting a lot more throughput based on that. So take us from.
But we still have a problem here, right?
Yeah,
so,
we still see too much I/O.
Exactly. And if we keep, sorry for that. And if we keep the load, at some point it will just get to the point it was before, right? Because when we added the PG bouncer, we're saving CPU resource from the Postgres side. So now Postgres has more CPU to work, but the I/O is still the same, right? So it didn't do much.
Right.
But what can we do from
you wouldn't expect the connection pool to make a big difference on the I/O unless you were saturating the I/O with a lot of connections, right? So, I mean, it is possible if you reduce the number of connections that were running concurrently, you could also reduce the I/O just because you'd have less things hitting disk, but that would probably reduce your overall throughput to achieve that.
That's true. But okay, from here. So what I'm really curious to see who is using that much of I/O. So there are some tools on Linux. They really help. So remember, PMM already gave us a really good direction where we go, right? And there are some really nice tools on Linux that we can use to find the problem. One nice thing that I really like on PMM is that we can extend PMM to use those tools. This is not the top for today, so we probably should get we schedule another one just to go through PMM to see how we can extend and all this kind of stuff, right? So I'm not going to spend much.
Well, so that means, Charly, you just signed up for 2 new streams, right? So you signed up for one on PostGIS, and now you've signed up one for extending PMM for additional Postgres metrics. So you heard it here, folks. We are now up to 22 weeks. So if there's anybody who wants another topic or two, let's see if we can get to 25 weeks of Postgres content by the end of this stream.
The good thing is that for that PMM one, I can outsource. I know a couple of.
No. You signed up. It's you. I already got you on a motorcycle graphic, so we're using it.
All right, that sounds interesting. Sounds really good. let's move back here before I say something that just adds more for this, right?
Yes,
Okay,
yes. Those who are
let's move
watching,
back.
you know, like I saw Augustine was watching. You can thank me that I didn't let Charly outsource this to you. So just be mindful of that. That I just saved either you or maybe Nikolai or a couple other people who might have gotten looped in here.
Yeah, okay. I'm gonna work my way later on. Okay, let's move on here. So I'm gonna check my IO top here because I want to see who is destroying my disk. Well, on my IO top here, I always see this checkpointer guy. See this guy here and this background writer. They are always here. Sometimes they write like 100 megabytes per second. Sometimes they write 3, 20, they go 0. So those guys are always here, right? The checkpointer and the background writer.
Indeed.
So, well, we got another hint. So we have problems about IO, and we have at least 2 guys here from Postgres that they're really destroying my IO subsystem here. Okay, what can we do with those guys? So before we move on, we need to understand what those did this. Let's look for this checkpointer here, because you mentioned before. Well, let's go back to the graph. You mentioned before that from time to time we do have some checkpoints activity here, right? So we had a huge spike. Well, they are out of my graph, but I can.
Yeah, if you go back and look at the last hour, you'll start to see them show up.
It's fine. I can simulate them, or we can even force them to appear here. Let's try to force them, right? So as we know what checkpoint is. Oops, I just stopped at my.
Yeah, well, that would definitely have an impact on those.
Yeah.
Stopping.
Okay. Well, I shouldn't stop. So let me go here to. Okay. Can you hear me? It looks like my connection just.
I still hear you.
Okay. Can you also see me, right? Because
I can see you, although your screen went really tiny. So.
Yeah, no, it also happened to me. I think this is the database server. It's not responding. That's why I thought my connection was lost.
So Charly is streaming,
okay.
But his database connection is dropped.
Okay, yeah.
Internet gremlins, everyone. Always on a Friday afternoon.
Okay. Okay, looks like I'm back. So I want to be Postgres.
By the way, where are these servers? Are these in AWS?
AWS, yeah, these are in AWS. And this is another thing that we should talk later, because when we start using too much IO, and if we're not paying for that IO we're using in AWS, they just reduce our IO, right? So sometimes it happens.
Yeah, I mean, and I think depending on what class of box, there's also other things, right? Because you can get burstable CPU. Burstable CPU works great until you run out of your burstable allotment, and then all of a sudden it dogs. So,
exactly. Yeah.
There's all kinds of gotchas in little idiosyncrasies.
Exactly. Yeah. So I'm gonna force a checkpoint here. So expect now my database to really have like huge impact. We should have. Well, this is when I dropped the connections, but now the queries per second should really go down, because see, from time to time we have 0 transactions per second.
Mm-hmm.
Because, well, what I'm doing, I'm forcing the database to checkpoint to flush all its cache to the disk, right? So
that's why you see the duration of, like, look at the duration of transactions, how long they're taking. You see the
exactly.
spike. So everything's having to wait.
Exactly. So don't do it in production unless you have a really good reason, right? So what we want to do here is we want to show what is the impact for a full checkpoint on the database side. It's kind of stop the world and wait for me to write everything that I need to write to the disk. Is it still ongoing? So it looks like we have a lot of data to write to the disk. So how does this work on Postgres? Postgres needs to write its dirty data to the disk, right? Every time, not only Postgres, all the database. Every time that we do a transaction, let's say we do an update. So when we send a commit, that update is first, the data is first updated in memory, right? And after it's been updated in memory, it needs to be flushed to the disk. Well, there are many approaches that different databases, they use different approaches. One thing that we can do is we can go to the data tables, like the data files, and write down that data there. Well, that's expensive because usually the data files, the data is just distributed randomly, especially for Postgres, right? So it's not saved in disk sequentially, like one after another. Let's say create the table user, and I have the ID that is my primary key inside of the table user. That doesn't mean that in the disk, the data file will be organized by the ID. It's not. Well, when we're inserting, Postgres tries to put one after another, but when we start updating things going to shift in here and there. So it's inefficient to write every time. Another problem is if we start writing to the data tables from memory, if something happens to the box in the middle of the process, we'll be left with inconsistent data on the data files, right? So it's not only inefficient, it's dangerous as well. So because it's inefficient and dangerous, most of the database, at least the ones that I know, they use another approach. They save this data somewhere else. They usually have either a circular file or they have a file that they pre-created that is sequential. So, and they will save that data first in that file. Some databases use undo log files. Other databases like Postgres use WAL files, that is write ahead logs. So if something happens while I'm writing the data to that file, and the data, let's say the database crashes or the OS crashes or whatever, something happens with the database. When we restart the database can check back to the WAL files. If there is a transaction in the middle, it just rolls back that transaction. And the data files are still consistent. Later on, the database will transfer everything from the WAL files to the data files, right? So those are when we're doing checkpoints. But you can tell, but well, a crash can still happen during that process. So we still can have a crash now during the checkpoint time, right? So then it didn't do anything for the safety. Well, if a crash happens while the database is copying data for the WAL files to the data files, when the database restarts, it will see that the data file is inconsistent. But then it can find where was on the WAL files, because the WAL files are saved, are kept safe. They've been written already. And it can redo that transaction and recover the data files. So this is a trade-off. If we wait for the database to do not flush or to do not, I just forgot, checkpoint, to do not checkpoint too often and keep a lot of data. When the database crashes and it recovers, it might need to read a lot of WAL files to get the database consistent to where it crashes before. So the recovery time if the database crashes and we need to restart the database is going to be longer and if we have more checkpoints. So for the other hand, if we have checkpoints too often, we can see a problem that we're seeing here. So we can put the disk really under pressure. So it can really create the problem that we're seeing here, that we have a lot of this activity, and then we start struggling with the number of transactions that we can put to the database. So we need to find a way to balance those settings. And this is the first thing that we should go. So there are some settings. The first one is we can increase the wall size. And by default, if I'm not mistaken, there are two configurations for the wall size. There is the minimal wall size and the max wall size. The minimal wall size, it says if we do a checkpoint, not flush, if do a checkpoint like I'm doing now. So it will write everything, right? It will clean up all the wall files. We're going to start fresh from here. So then it will start creating the new files to start filling those files. So this is the minimal wall size. So when the database starts fresh from the wall files, what is the size of the wall file? This is how is defined by the min wall size file.
And then it grows from there, because I think the default is 80 or 100. I think it's 80.
Yeah, it's pretty small. I think it's 80. Yeah, I think it's around 100 megabytes. Yeah, I think it's around that. I don't recall on top of my mind. We can double check. And the max is 1 gigabyte. So for workloads like the one that we have in here, those are too small, right? So I want to have larger, so I can afford a longer time during the recovery process. Like my client can afford that. So then he told me, I want to improve performance and we can afford. Like we have applications, so if this database crashes and they can do some other high availability operations and get things back. Okay, so then the first thing that we can do and we should do is start increasing the wall size, right? I'm gonna increase both. I'm gonna increase the min wall size and the max. And then you can ask me, okay, what is the best value? Well,
what is the best value? You said to ask you.
Yeah, that's a good question. That's indeed a good question, and I had no idea, because well, I'm just looking at the database now. But we can check. So we can see how much we write per second on the database, right? So we can check the log LSN that was written, wait for 5 or 10 minutes, and then check the log SLN and just do the math to see how much data we are writing to the database. On that, we choose the wall size that we want. Like I want 30 minutes of wall. I want 1 hour. I can afford, I don't know, half a day, So there is not really a strict definition for what is the best. So the best is what is the best for your workload, for your case. So maybe you cannot afford your database to go offline for 5 minutes. You have no other strategy. This is the only database that you have. And if something happens, you need to recover from the crash in max 5 minutes. So your wall file cannot be larger than it takes for 5 minutes worth of data, right?
Now, with that, I mean, that assumes a single box. If you have failover set up, would you risk a larger wall file size and a longer recovery if the database does crash?
You can, but then you need to pay close attention for your replication. Because if your replication is lagging and you want to switch over from your primary to the replication, you still need to wait for your application to go up to the speed, right? To recover from the lag.
Right.
So you need to be careful with the high availability, especially because most of recommended setups on Postgres are asynchronous. There are synchronous setups there, but like it's not the subject of this talk. So let's assume you have an asynchronous replication. That's the most common one. Then you need to really take in consideration the risk. If your replication is lagging a lot behind, maybe the time that takes for your application to get up to this speed, and you promote is larger than your primary to just read from the wall files.
So there is
need to be careful
some give and take there. Because I mean, most people will have that automatic failover though, right? So if your replication is lagging, you could fail over and your primary could recover quicker than your replication can catch up.
Yeah, that's true. That's true. That's why we really need to close eyes on those. If you really want high availability with high level of SLA, the replication is something that really need to keep eyes on it. It shouldn't lag too much because the switch over is really fast. Usually the people think that the longer that takes on the process is the switch over. Actually, the switch over can do in seconds or milliseconds, depending on the latency of your network and the configuration. So it's really fast. What takes long is if your replicas is lagging behind of the primary. That can take quite a long time, and then your SLA of 5 nines is just goes down to the road.
So I don't know if you were going to check the LSN numbers, but I do notice that well, go back down a little bit. I do notice that your transaction time, like as you were talking, it just keeps on going up and to the right, which is good if that's a metric of how much, users or money you're making, but not so good if it's the amount of time that transactions are taking. That tends to be bad when it goes up.
Yeah, that's indeed. So, well, up to this point, there's not much we can do, right? So we were forcing the checkpoint. So I'm gonna wait for the checkpoint. I'm not going to change to check the LSN because, well, we need to wait at least 1 or 5 minutes, and as we're taking too long. So what I'm gonna do is I'm gonna use 1 gigabyte because I did the math before. Okay. We can show it later, probably next session, or if we have time by the end of the session. But it's a simple select. So we just select the current LSN.
So
wait for a couple of minutes.
As part of this, what about synchronous commits or wall sync method as other ways to potentially reduce I/O?
It's a trade-off.
Well, I mean, everything's a trade-off, right? From a performance perspective.
Exactly. It's a trade-off. Again, it depends on your workload. Can you afford that? Like a lot of applications, for example, they need to use serializable transactions instead of read committed because they cannot afford any ghost reads or anything, right? And they should afford to lose some performance to get a consistent view of the data. This is the same for the writes, so for the commits, right? And there is even more strict that we can go. Like, for example, on the replication, we can use synchronous replication. It doesn't need to be a synchronous replication, right? And even on the synchronous replication side, you can have the synchronous replication when you just wait for the replica to acknowledge that it received the data and didn't apply yet. Or you can wait for the replica to receive the data, apply, and then go back to you, and then you send back to the application the result of the commit, if it's success or failure, right? So all of those can drastically reduce the stress that you put on your I/O subsystem, can improve the high availability level, the level of high availability that we can give to our customer, but definitely they have costs, right? The performance can drop significantly. Like for example, for the replication things. So we now need to wait at least the round trip, the network round trip. So if we have the primary in New York and the replica in Dubai, for example, the network round trip can cost quite a lot, right?
Mm-hmm.
But if they both are on the same data center using fiber and really expensive switches and all those kind of things, so sometimes the network round trip is cheaper than the IO that we have here. So all those things play in consideration, right? So there is no really a formula to tell you what is right or not. But all of them we add every time that we add something or for improve scalability or to improve safety or whatever, we'll probably add on the performance problem. So you drop on the performance, right? So usually,
yeah, it's a trade-off, right? So you get better availability or better recoverability at the expense of performance.
Exactly.
So now you're waiting for this to do.
See, the checkpoint here is taking 99% of my IO activity.
So I have an IO bound workload as well. If you want to look at it.
Yeah, let's go there.
While your checkpoint on your workload is over there doing its thing, if you take a look at the 130 box on the PMM instance that I sent you. There's an IP 130 because I didn't name them nicely like Charlie did, because I'm just a lazy turd when it comes to naming things correctly. I believe that everything should just be an IP address name. I'm not a fan of anything else. I just want like hardcore IP6 values and just remember them off the top of my head, right? I'm just teasing.
Okay, I just need to
click the link.
I just need to learn how to use my browser because it looks like
browsing is hard.
See, this is what happens.
Interneting is hard.
When it take too long using the
interneting is so hard.
Come on, I don't think if it's Zoom or something, but it doesn't. Okay. I got it back. Oh, cool. F11. Oh, I need to remember my username and password, right? That's something that I don't. Okay, let's try to. Okay, I got it.
Hey,
you saw my password, right?
Yeah. 1, 2, 3, 4, 5 is not a secure password.
Well, there are many stars on those. I can tell you for sure.
1, 2, 3, 4, 5.
At least up to 9.
The same as my luggage.
No, my password is encrypted. It's the other way around. It's 98765431.
So we do have a request to do some tuning on read-only workloads, which we can actually do that. We've got I've got some workload we can change over. The ones we're looking at right now are kind of a mix. So there's two workloads that I've got for Charlie here. One is a kind of a 50-50 mix for web workload, and this one is if you look at the 130 box, this one is a much heavier write workload. And this one's going to be more of almost like an archival with some analytics, if you will. Look at that, you broke it. Why did you break it? Choose the database. Choose database. Choose database. Choose. Database.
I thought we've selected it.
Service, I don't know. It's kind of weird. But
okay, let me just put here to the last 15 minutes. Okay.
But no, that's a good one. So Charlie, you're up to 375 live streams now. Just saying.
Cool.
One a day. Would everybody show up if we did one a day? Like or two a day? Or maybe we just have Charlie work live on Twitch and YouTube. That could be fun.
Oh, we on Twitching? Okay, that's my first one. So
this is your first Twitch experience? You've been on Twitch.
Yeah, I'm debuting there. Okay, cool.
Yes.
Well, I see that you have no share buffers here at all, right? Well, I can tell that your configuration is it's not cool. I was about to say another word, but like it's not cool. No cool.
You were gonna call me aged again? Old?
No,
like I don't know what I'm doing. I've lost my
yeah, it is
senility.
because this 128 megabytes is like for the 90s, you know.
So here's the thing. This was a box that was set up for you to configure and tune, but then you set up your own box last time, so I never went back and did any changes. So this is pretty much default out of the box.
Yeah, I can tell. Okay, yeah. Well, we have a lot of things to do, right? We need to change the memory. We need to change kernel settings, the things that we did last time. Okay. Oh, hey, your checkpoint is quite cool.
I don't know if would anybody consider that checkpoint cool? I mean, I guess it's kind of cool because it is very uniform.
Yeah, it's pretty.
It's pretty.
You know?
It's pretty.
It is.
Yeah.
See, and it's like, yeah. Well, we definitely see see. You really have this like standards here. You're in patterns. Like we see patterns everywhere. See from here to here, there's one, from here to another. So those are the checkpoints. If you see here, everything goes, so the transaction increases a bit, then checkpoint and goes and checkpoints. And if you look around your graphs, you're gonna see the patterns there all around your checkpoints.
Right.
So, and definitely when we increase the memory, the share buffers, we can improve that because we're gonna have more buffer, so we can keep more data before we move them. Okay, where do you want to start? So I already told you the share buffer is not good, the checkpoints are not good. So
do you want to recycle it and change those? You want to go in and change them? You can.
Yeah.
This is yours. Right. This is your box to play with.
Okay. So I suppose I have access, right?
I did give you access last time. So, and okay. I did ask you prior to this.
Look.
Oh yeah, your checkpoint failed. Made PG bench bork. My workload is not PG bench. By the way, everyone. Although it does, I can make some wild and woolly changes if we want to make the workload really random. But right now it's running a uniform workload of so many writers and so many reporters. But we can make changes. And if someone would like to come on and play Dungeons and Dragons Postgres with me sometime, I'll be the dungeon master and I'll be changing variables behind the scenes, and then you have to figure out what I changed. It should be awesome.
All right, for
Postgres edition.
I'm in. So
you are in.
I have sudo. Okay, now I can restart the database.
No, don't restart the database. It took me forever to get this started. No.
All right, so okay, I'm checking your graphs here. I see from the database that we need to at least start with the basic settings, right? This is the basic that we do when install Postgres. So basic configuration for memory, shared buffers, basic configuration for WAL, and those are the base settings, right? So this is pretty common actually that we have, especially when we have like a setup that is done by a developer. So we should not expect the developer to go deep and do configuration because, well, this is not their field, right? Or if not that there are not developers out there that understand a lot of the database things. I have some peers, some buddies that they are developers and they do understand a lot about database, but this is not their field. So this is DBA responsibility. And usually when we get a database like this, usually like set up for a developer, or it was a pet environment, and then for whatever reason it was promoted as a production. So we get really out of the box installation. So everything is the full. First things we check are those configurations. The most basic settings configuration, tuning, let's put, we shouldn't even call it tuning, but anyways, those are the first things that we should check, right? Take a look on the memory configuration. So the share buffers, how the cache is being used, if the box has or not configuration for swap, how the CPU governor, all those basic things to make at least the database to perform up to the box. Let's put on this way, not too down with what the configuration that we have, right? So, but then we need to know, like for example, how much memory we have on this database. We can use, like just I did here, and see that map doesn't have swap at all, which is bad. And we've discussed that why it's bad last time. We should have
it's
learned.
Good. That's what default, when you spin up an instance, it's default.
Yeah. So don't stay on defaults. They're not good.
They are good.
So, and I would say a better approach or to take a look is to use the tools that we have. Like, for example, the PMM. So I can here on my node, I can have a node overview and should have been opened here. Let me choose.
It's on the right one.
I already have this one. Yeah, it's on the right one. So, and I want, actually, what I want to see is on node overview on the summary. Okay. So we can get most of the information that we need from here, right? So for example, how much memory we have. So I can see that we have a 32 gigabytes memory on this box. So I can see that, well, at least the swapness is set to 1. That's a good thing, even though we don't have swap available. I can see the configuration for the OS kernel, like the dir caches and things here. We can also see, take a look on the I/O that we should have somewhere around here. What is the I/O scheduler? Oh, we don't have RAID, so that's common, especially on AWS, because they do not expose this information from the
It's a mystery.
The VM level. And you have transparent huge page enable here. This is not good either. Okay, let's start from here. You have 32 gigabytes of memory, right? So usually for this recommendation, so I would say, like, if you go up to 12 gigabytes of memory in this box, it's not bad. Remember, I do not know your workload.
Yeah, you do. You're looking at it right now.
Well, I'm looking for the problems that your workload is causing, not your workload.
Oh.
Right? So this is different. I'm looking at the problems they're causing. I see that you have how many connections? So not that many. So usually less than 100. You have less than 100 connections. That's not bad. But I have no idea what those connections are doing. So I can see that what kind of activities, they read activities here. So not as bad. And the transactions are taking quite long. So I can have some hints about your workload, but I don't really know your workload indeed. I only know what your workload is causing to the database, right? And this is the premise. So usually, because Postgres doesn't do direct I/O and it relies a lot on the kernel to do buffer I/O, we usually don't give too much memory for the Postgres. There are exceptions. And for example, if you really have a really read-intensive workload, it might be a good idea to give more memory to Postgres than to the OS cache. Because Postgres can cache better the information based on the tables and the data that you're using. The OS only caches blocks, right? So kernel doesn't care. Those are just blocks that it got from the file system, and it's caching. So the cache on the database is more optimized, and it's an specialist caching, let's put on this way, because it knows the data it's caching. So there are some circumstances that it's better to have more memory for the database than the OS cache. But the majority of the workloads, I would say 60, 75% of their workloads that I've seen, it's better to keep more memory to the OS cache than to the database cache. And that's why I usually start with smaller values, like for example, 8 gigabytes, 12 gigabytes, when you have like a box less than 100 gigabytes memory, right? So it's not a formula like we have for other databases, like MySQL. They usually recommend you giving 75, 80% of the memory, available memory to the database, right? It's not like this on Postgres. You can give like up to 40% if you don't have a lot of memory on the cache. But as the amount of memory on the box increases, 40% can be a lot. Like if you have 100 gigabytes memory on this box, that would be 40 gigabytes memory. It's a lot. Most of the times it's better to have those cache for the kernel to cache than to the database. Anyways, too much talk. Let's start changing. So I need to know where is your configuration as user you're using a Ubuntu. I guess that it's etc.
Postgres.
etc.
Conf.
Postgres.
Yeah, it's under Postgres 13 main.
Yeah.
And I think it's going to be under confd. I don't know if that might just point to confd.
Yeah, it's not confd actually. This is usually is using this one.
Okay, there you go.
But we can check later on Postgres, and just because I'm too lazy now, I'm gonna
don't say that.
I'm gonna go here. So yeah, see, this is where we have your data directory file, HBA, so we don't care about those. List and address. Well, your workload so far, you haven't complained about the number of connections, so we're gonna keep 100.
Well, that's because I limited the number of connections. I could add more, but
yeah,
I knew I had a limit of 100, so I didn't go over. And I have
no
pool or bouncer.
You are my client. We're not complaining that
you're complaining.
Not
you're
enough.
complaining.
100 is not enough, so I'm gonna keep 100. All right, so let's go for the share buffers. Okay. I'm gonna start very conservative. Let's start with 6 gigabytes, right? There's no magic. It's just because I want to give it a start with 6 gigabytes. Remember, I'll have to restart the database. Right? This is one thing that you need to keep in mind. So now it's fine. Like my customer didn't say that I could not restart the database that level. So I'm taking it for granted that I can restart the database without problems, right? So if we need to increase, you can increase later. But if you're working on production, be careful because you need to restart like the database. So I'm gonna, for now, for megabytes for Workman should be fine. And let's do just this one. Let's just, oops. I only want to change the share buffers and see how that can impact in your load, right? So I'm not going to change anything else, only the share buffers, and we'll see how impact the load. This is a very good approach when we're working with tuning and optimization. Do not change too many parameters at the same time, because if something goes well, you have no idea which parameter caused the improvement. If something goes really bad, you also have no idea what parameter get your database in bad performance, right? So every time that we're going for tuning or something, change one parameter, test it out, see how it works, how it behaves. Then we're going to understand what the parameter does. So I should suppose, well, have you ever used, yeah, you did use it here. So I'm restarting your database. You're, as my customer, you're fine with that, Matt?
Sure.
Okay, thank you. Shall I ask for a written approval?
Yes.
Okay, fair enough. Well, I've restarted.
Denied. Did it restart?
I'm gonna check now. Yeah, it says it's alive. And I can connect to the database. Yeah, it did.
That's weird though, because the app didn't recycle.
See, that's a problem with developers. Sometimes they take things for granted. You may need to restart your application as well, right?
Maybe. Let's see.
Maybe.
It should have.
I know that my client doesn't have a connection pooling, so that may be a problem when I restart the database.
I don't know. Did it actually restart, or did it do like a just an act to return?
No, it restarted. Well, I can do a stop. Let's do a stop here, right?
Because the Postgres still has workload on that box.
So it stopped. Now it's stopped. Right?
Hold on. No. Do it top real quick. Because I'm still seeing tons of Postgres. Just look at the processes real quick. Yeah. So So it didn't stop.
Okay. Yeah, that's true. System D is lying to us.
By the way, this is the box that you set up last time.
Is
Pretty
it?
sure
We created swap and we changed a lot of things last time. Remember?
Maybe the other one is then. Maybe 111 is. It could be this one.
Okay, let's give it some time. Do you want me to do something and tell people never do that?
No, kill.
Because I can see you have a lot of movie JSON user connections here. Okay, let's spin things up, right? So people that watching, never do that, especially in production. Really, never ever do what I'm about to do here. That said,
by the way, it stopped now.
Whoa, did it?
It's done. Yeah.
Whoa, almost. Okay, I'm not going to run. I just keep it here for posterity. We never know. Okay, yeah. Still have some processes running. Yeah, Postgres is still running.
Well, that's
okay.
Oh no, yeah, it is.
Yeah, so I'm gonna just send a SIG-Q signal. So this is fine. This one is fine to send a SIG-Q signal to Postgres and the other process because it doesn't forcefully kill them. Just ask them, can you please stop? Sometimes they reply, no, we don't want to stop. And usually because probably it's doing some OS activity. See this guy here? See the D? It's in interruptible state. It's doing I/O. And probably everybody's waiting for this guy to finish his I/O and then stop. So
this one was heavily I/O bound. So are you saying that the reason that it's not stopping is because it's waiting for the checkpoints to clear to stop gracefully?
Probably, yeah. But I wonder what happens if I forcefully kill them. Remember that we told Postgres is able to recover, right?
Mm-hmm.
Are we able to back up our words here? Okay, this one is fine. This one is for the PMM. So I forcefully killed Postgres, right? Okay. So now Postgres is in an inconsistent state because it was still doing some I/O. When you stop the database, it still has, especially if you have a really I/O-bound workload. So even when we stop the database, there are a lot of things in memory that the database needs to flush, the kernel needs to flush. So there's still a lot of activity that the database needs to do. And that's another thing that you need to take into consideration when you have a lot of memory and you give a lot of memory to the database. Sorry. The startup and the shutdown process, they might take longer because they still need to flush or that all that I/O, and they need to finish a lot of operations that they're doing in background, right? And at this point, the database is an inconsistent state because, well, I just killed the Q-9. So we need to.
Shame on you.
No, my fault. I asked my customer. He said yes. It was like I could.
I never said kill. I said you could stop it.
I did. I stopped them. So it says Postgres. It says it's active, but it's exit. Okay. Let's try to connect. See, it's not really running. And now we have a problem. Postgres didn't really start. So what do we do now? I hope you have logs on Postgres, right? So we should be...
varlib. I think that it's under varlib.
Yeah, I'm going to check the configuration. Archive. Okay, yeah, we do have log, and it's inside of the data.dir folder log. Okay, and the data.dir, I saw something here. It is, yeah, this one. So we should go for this one, and here we should have a log folder. And inside of this folder, we should have logs. And which day is today?
The 11th.
11th. Okay.
So the last one there should be it, right?
Yeah, that's pretty huge. Yeah, let's take a look. Well, this is the shutdown one. This is not the one we're looking for. It should be this one. Wow, that's interesting. See the timestamp.
Yeah, those ones are from earlier today.
Yeah, it didn't log the attempt to start the database. Okay.
So system CTL might not be working, right? That's possible.
Yep.
Or it might not be called PostgreSQL server. It could be something else.
That could be.
I think on this box, I thought I saw you monkeying around with PG up or PG start. A PG start script.
Did I?
I thought so.
Okay. Let's let's do. Oh, yeah, that's indeed.
Yeah, because you were playing around with this before, when we were doing some work on the previous stream. And if I recall correctly, on this particular box, just double check.
Okay, let's see. Why? Okay, this is the one.
Yeah, you had you were using PG Start prior. PG Start stop.
Okay, yep. Okay, now we're back. Yep, the system D is having issues here. That's unfortunate. I would like system D. So we are back.
Charly, user error.
Yep.
It was just user error. That's all. It was just.
Sorry, Matt. What did you say?
I said that was just user error. We just foobarred the config earlier, I think, when we were doing when we were shutting it down from the last stream. And we're playing with it.
Yeah, I'll take a look on that one later.
But the shared buffers is now up to 8 gigs.
It's 6.
Or no, wait, that's 6. Sorry.
Yeah. I was conservative. I wanted to save 2 gigs for later. So you spinning up the load again?
Yep. Give me 1 second.
And let's see if it does anything with this tiny configuration.
The load for this is Charly Heavy Write Workload. That's the name of this workload.
You name it your workload? Really?
After you. I named it after Charly. It is Charly's workload. So
okay,
blame Charly. It's his workload.
Let's take a look on this one. And I suggest we just finish from here, because I think we are more than 1 hour, right? So, and we can keep going from here to the next session. So to finish, see, it may not be able to finish everything in one session, but you may have your 25 by the end of the day.
Yeah. Well, I think officially you're up to 793 live streams you owe the community here. So that's okay. I mean,
all right. let's take a look on my box if it's still waiting for the. Oh no, the checkpoint is done. Thanks God, I didn't crash my box.
So if you wanted to show something on yours, while the workload on mine is running, it's just going to take a few minutes to start doing its stuff, right?
Yeah. Well, my workload, it's back.
Your workload.
So. Where is my? Yeah, I suppose this is my. It's my box. There are too many boxes here. Now I'm confused. Yeah, this is my box.
You're confused?
Yeah, see, it took just 15 seconds for this transaction to finish. Almost nothing. So now it took a lot longer. Those are how many transactions that took at least 15 seconds. And see how many locks we had during that time. All right. So now we are back. And we should see the IO8, everything is back as we didn't change anything of configuration on my box, right?
Oh,
so
yes.
One thing that remember that we want to change the wall size, the min and max wall size. So as we are advanced on time, I'm gonna do it here, and okay, I don't need you. Well, I need to restart my database. So let me stop this load here. I'm using Percona on this database here. And I'm also using Percona to do my configuration changes. So everything that I changed on my configuration, they are here. You can see. So I keep the max wall size as the full, and you're right, it's 8 megabytes of min wall size. So what I'm gonna do is I'm gonna increase for 1 gigabyte of my min wall size. And for this box, I'm gonna use 5 gigabytes. Put 2 gigabytes here, and yeah, 5 gigabytes of my max wall size. And this is not enough. We need to tell the database how we want the database to distribute that load over the time that we were given to the database. Because, well, even though we have like a max wall size of 5 gigabytes, we can also have the timeout for I just forgot the name, the checkpoint, right?
Yeah.
So we need to give the database more time to process. I don't want 5 minutes timeout. I think that's the default for the configuration. And I really don't remember if the name of parameter checkpoint timeout on top of my head now.
What,
I'm Googling.
The timeout parameter?
Yes.
Let me see.
I'm just using Google. It's easier. Yeah, it's checkpoint timeout.
Oh, yeah.
So
checkpoint timeout.
the checkpoint timeout, I'm gonna give it 3600 seconds, right? So it's in seconds, if I'm not mistaken. And I want to give it 1 hour, right? And also, I need to tell the database how it can proceed, because, well, even though I tell the database, look, the timeout for the checkpoint for this 5 gigabytes here, I want you to split the load evenly with the time. I want you to wait more, to wait less. So this is what we call the completion target on Postgres. There is a change on Postgres 14, if I'm not wrong, that they put it hard-coded to 0.9. So it will try to wait as much it can to finish the checkpoint. It won't forcefully force the checkpoint to promptly finish. So, and it's, the name of parameter is checkpoint. Now I Googling again because I don't really remember.
You mean like the completion target, or?
Yes, the completion target.
Yeah. I mean, default is 0.9.
It's 0.9. The default is 0.5, no?
No. As of 14, it's 0.9.
Oh, it is? Okay.
Mm-hmm.
Just to be sure. Oh, well, I'm using 13, by the way.
Let me
And
check
that's what
13.
I said.
Let me check 13.
I am not sure if they put the full for 0.9 or if they
Yeah, it changed. It changed in it's 0.9 in 14, and it's 0.5 in 13.
Yeah, I'm using 13 here, so I'm gonna put 0.5. Look, the only thing that we change are related to the wall, right? So I'm in checkpoints, nothing else. I'm gonna save. Oops. I need to be root to do this. Systemctl restart Patroni. Yeah, it should take some time because we have a lot of things going on here, so it should take some time to restart the database. That's expected. So you got your load back?
Yes.
Okay. While you are waiting for my database to get back, let's go back to your workload. You sure you got it back? Okay, yeah. I was just all right.
Yes, I'm sure
So,
I got it back.
yeah, I can see that now. That was my bad.
Don't be mean to me.
Okay, let's see
Don't
what
be mean to
happened
me.
to you. Look, we changed your checkpoint behavior. Let me just reload this here. It doesn't look right. Okay. Am I connected to the right place? Yeah.
30? Yeah, you're on 30.
113. Yeah, 130. Not 13, 130. Yeah. So, and this is last 15 minutes, right? See, we changed it. Now you're writing more to your database. Let's just take a look on those. See, now we are doing more checkpoints. How is that possible? What happened? Was not it supposed to improve your load?
Wow, come on. You once you free one bottleneck, the bottleneck shifts, right? I mean, so when you're reading off of disk, it competes for the checkpoint. So yeah. Yeah, it's interesting. So if you look at like the query throughput, I mean, number of queries per second doubled, and the response time really stabilized, although the response time is a little higher, it looks like. No, it dropped down. It dropped down quite substantially. I think it was just a warming of the cache.
So now we have double of the throughput, right? The queries per second.
Yeah.
That's good. So my customer is getting happier because now we can do double the job with the same time, right?
Yes, double the job. Double the job. And the IO weight went down quite substantially. I mean, now you're in, but keep in mind, this is also warming up still. So, you know, after a restart, you won't get to a aggressive checkpointing until after the workload has been running for a while, right?
Well, you are getting a very aggressive here, doing a lot of checkpoints.
Well, but you're not as backed up, is what I'm saying. Is like over time, it you know what you'll see after a restart, things can perform at a certain level, and then as you know, system buffers start to fill up, as you start to run out of space and get more aggressive in having to do background operations, then things start to slow down. So it'll be interesting because let me go look. I'm going to look at the last 6 hours. Yeah, so if you look at like the last 6 hours of IO wait, for instance.
Okay.
So
last
6 hours. Just 6 hours. That should be good. And look at the IO wait numbers, like the CPU IO wait. Yes. You can see like the first, you see around 1500. You see that workload there, like 1500 o'clock. So you're too early with your thing. You got to move it back to the next bubble. Yeah, right there. Okay. You see the jump there. So it ran fine for whatever that was, maybe like an hour, and then after that hour, it almost doubled the IO wait. So the workload ramps up and it takes a while. And so for that first hour, things might look hunky-dory happy in terms of IO. And then after, well, actually that's more like 15 minutes, isn't it? Maybe 10 minutes. Yeah. So then after a certain amount of time, bam, right? Like IO just like spikes up, which is interesting because it's that warm up time and it's, kind of pushing everything. So I'm wondering after a certain amount of time here if we'll see a spike again with that IO, especially considering a lot of these are just very basic.
No, yeah, we probably will, especially because the only thing that we did, we changed it was we gave more memory for the database. And actually, I'm expecting that the ramp up going to be earlier than later.
Because of the disk, because you're now freed up the
yes,
regular queries to start pulling things quicker.
Yes. Yeah. So, and that's when it comes to the parameter that we just changed on my database, right? So now we have to wait, and that's why my recommendation is, okay, we wrap up for today.
You said for a year, right? You said you wrap up for a year, so you don't want to do another live stream for a year.
Wrap up here, you know. I know I have a really bad English, my pronunciation.
No, I thought you said year, and I'm like, what? He wants to wrap up for the year?
And we keep from here next session, right? So we I'm not going to touch on my box. I'll leave it as it is, right? So then we have the full picture of what we did. That's tiny little change. So next session we can start the load like 15-30 minutes before the.
So if you have time, we can even just like whatever time you want to get on next week, just random, like, hey, I got an hour, I got a half hour to look at this again. We can jump back on.
Yeah, sounds good.
I mean, because we don't need to announce that it's coming because most people are going to watch off anyway. Exactly. So
that's fine because it's getting really lengthy. It's like 1 hour, 1.5 hours, right? So
you just want to go to your weekend. It's Friday. Everybody wants to go to their weekend. I want to go to my weekend. We all want to go to our weekends. It is late. We should let this fun end now.
It's raining dogs and cats here. I there's nothing much that I can do out there,
Yes. All right. Well, so we did see some improvement here. Like I said, I'm interested to see after the next hour or so. Yeah, whatever, to see what if the workload on my side changes measurably. But we can come back and just let things run and see what happens.
That's the thing. So we should let it run and spin up like 1 hour earlier. Next time we get some time just to warm it up and see how that goes, and then we go back and we compare and we change the other parameters and give some time to run again. And as we have different workloads, you have two, I have one, so we can change for go and forth between them, right? So while we're talking.
Yeah, absolutely. Absolutely. And we can also throw in that read-only workload that we had somebody ask about as well.
Yes, that's also a good one. And that's interesting to compare how they differ from each other, right? Because one thing is write intensive workload. We have some problems that we see here. On read-only, we might have a totally different types of problems.
Right. Yep, absolutely.
Cool.
All right, everyone. Thank you for coming along. Hopefully you learned something this week. We'll try and do just a random kind of like stream next week to kind of close out this topic before we get to the next topic in our list, which I believe the next topic after this is starting to dig into replication setup. So we were going to do a basic config, and then we were going to jump into replication setup and getting replicas and how do we monitor lag and things. So we do want to get that to there as well. Oh, look, Nando's been hanging out with us as well. And Nando, you were so quiet this whole time. We didn't even know you were there. You were just lurking the whole time. Lurking.
Thanks to be around, guys.
All right. Well, we'll catch you next time then. We appreciate it, and check out our live streams coming up over the next few weeks, and we'll catch you next time.
Yeah, and again, if you have questions or topics that you want to discuss here, just send out, right?
Yeah.
You have Matt social medias. You don't have mine because I'm not so social. But
We're gonna
he's
make Charlie social. By the time
Yeah.
I'm done with him, he's gonna be mini Haas. All right.
All right.
All right. Bye, everybody.
Bye, everybody.